Hello everyone. Let me start a very beautiful chapter, that is electricity. One thing I will tell you, without electricity it is not possible for us to lead a life. We are all dependent on electricity. Am I right? Yes, it's definitely we all dependent on electricity. Just look at it. Okay? Let me start with the introduction. This electricity that comes in one of the scientists called as, that is Thomas Alva Edison. You know that his name is very popular. Okay, this Edison had electric bulb. He discovered electric bulb. So that so many scientists had worked on this electricity, and they gave a very important concept regarding electricity. In this chapter, we are going to learn two important concepts. I think three important concepts. That is electric current, first one, and the second one, electric potential, and potential difference. Okay. These two concepts are very, very important. And electric potential and electric potential difference, there is a slight difference is there. I'll tell you what type of difference is there and everything in the later upcoming sessions. Today, let me introduce a very best and easy concept of electric current. Okay, let me start with the introduction of electric current. What is the meaning of this electric current? Okay, let me write down the exact definition, what is there in your textbook, because it is very important for the examination point of view. In a 10th standard board exam, they'll ask such a kind of questions, and go through with this properly. Okay, electric current means the rate of flow of charges. Okay, the rate of flow of charges is called as electric current. Now, what is the meaning of this, the rate of flow of charges? Okay, let me tell you, before moving into the rate and all, let me tell you one thing, that is flow of charges. What is the meaning of flow of charges, guys? Whenever the charges flows, then only it is possible for the generation of this electricity. Understand? So, what is the meaning of flow of charges? Just 2 minutes. Go back to your 9th standard. Okay. In 9th standard, what I teach you, that is atom. You know about atom and all, right? That comes in 9th standard. Correct? That atom is nothing but that consists of, definitely that atom consists of nucleus, and that nucleus has protons and neutrons, and something is revolving around that. What is that? Electrons. Yes, correct. Electrons are revolving around the nucleus. Before moving into that concept, let me tell you something. What is the meaning of this atom, guys? Smallest particle. What is this? Smallest particle of matter. Okay. Matter. What is this matter, guys? Everything in the universe. Everything is a nucleus, and that nucleus has protons and neutrons, and something is revolving around this. Those are called as electrons. Correct? These protons, neutrons are present in a nucleus, and the electrons are revolving around the nucleus. And this is very important. Carefully just go through with this. That is, electrons are revolving around the nucleus. Okay, these electrons are revolving. These electrons are very, very important for the understanding the concept which is there in your electricity chapter. Actually, for us, for electricity chapter, electrons are very, very important. Throughout complete chapter is dependent on electrons. Okay, you just no need to worry about protons and neutrons. Just understand the electrons, how they are flowing around the nucleus. You just concentrate and understand only the thing which is present in that atom, that is electron. Electrons are very, very important for electricity chapter. I am going to tell you one thing. If the atom contains more electron and less proton, then this is called as negatively charged particle. This is very important. Negatively charged particle, and this is very, very important for the generation of electricity. Okay, this negatively charged particles are very, very important for the generation of electricity. In this chapter you will learn this thoroughly, and I'll explain you why this is negatively charged particles are important and everything in the upcoming session. That what I explained you in the electric current definition, the rate of flow of charges. What is that? Flow of charges. Flow means what? It has to move from one place to another place. Correct? Then I'll tell you one thing. These electrons move from one atom to another. One atom to another atom. Getting? These electrons move from one atom to another atom, and this is very, very important. This is the flow of charge, guys. This electron has a capacity to jump from one atom to another atom. This generates your beautiful concept, that is electricity. This generates electricity. Okay, how the flow is going to be happen, how the flow is happening in a chapter, I'll tell you. That electricity got generated from the flow of this charge, that is electrons, because electron has the capacity to move from one atom to the another atom, and electrons are easily moving in very important thing, that is conductors. What is that? Conductors, guys? Conductors, these are the thing which carries current. Which carries current. Correct? The conductor, these are the things which carries current. And for example, metals like copper, iron, aluminium, these are the things we call them as a conductors because they carries current. Okay, let me tell you one thing. Before moving into this concept, a basic concept, I think you all know that one because this is very basic. When two charges are like charges, when they both the charges are got connected with a like charges, then it is ripple. Am I right? If the charge is positive negative or negative positive, it will attract. Correct? This is repel each other and this is attract each other. Before moving into this concept, you just remember this point. Okay? The conductors are the things where they carry current very easily. Okay? Let me tell you one thing. The charge, that is electrons, are moving or jumping easily in conductors. That is the reason these electrons easily generates this electricity. That I told you, electrons need to move from one atom to another atom. That is possible in case of conductors only. Even though we are also having so many atoms in our body, but we can't generate electricity. Just imagine what will gonna happen if we generate electricity and all. So because we are not generating any electrons in our body, we are also having so many atoms that I already told you in the previous classes and all, that cells are made up of so many kind of things. The smallest particle is there, we called it an atom, and everything that we explained thoroughly. But don't think that we are also generating electricity. No, it is not at all possible, because for the generation of electricity, electrons are necessary. Okay, now I'll explain you. I'm taking how the flow is happening in a conductors. I'm taking a copper wire, that is copper. This atomic number is 29, and electronic configuration is 2, 8, 18, 1. You know about electronic configuration and everything, am I right? Copper is having an atomic number 29 and its electronic configuration is 2, 8, 18, 1. Atom distribution of electrons is like this. This is the way how to distribute the electrons and everything. Just go through with my another video where I explained thoroughly in a chemistry chapter. That is nothing but how the electrons are sharing around the nucleus and all. There is what type of shells are there? K, L, M, N shells are there, where K holds only 2 electrons and L shell holds 2n square, like that. That is, it holds some kind of 2. It's possible in a first shell, and L shell holds 8 and 18. Next shell is last shell is also holds some kind of electrons and everything. Okay, let me tell you one thing about the copper. Let me come back to our concept, that is electricity, how the electricity is passing and how the electricity is going to be get generated by using electrons and everything. Okay. Just imagine this is a copper which has a nucleus, and the electrons are revolving around this that I told you, 2, 8, 1, like that. Okay, and whenever some energy applied to this copper, I mean this whatever the thing which is there here, we call it as a conductor. If some energy applied to this, whatever the electron which is there in the outermost shell, it will jump to a next electron. Okay, and it will shift to here. Okay, got it? That it will shift to here. Next, if more energy applied to this, again it will shift to the next electron. That is, here also it is there, electron is there, electron is there, electron is there, electron is there. Like that, it is shifting from one place to another place, one place to another place. Now we are just observing the flow is happening. Am I right? The flow is happening with the help of what, guys? Our superhero, electron. The electrons are jumping from one place to another and another, some here to here. That flow is the only thing where it generates electricity. Understood? It is only possible in conductors. Okay, how the things are generating here, by transferring of an electron from one atom to the another, one atom to the another, one atom to the another. The flow is happening with the help of energy. Tell me, what is energy? Energy. What type of energy you need to apply? This type of energy? No, we need to say the batteries. We have to give an energy with the help of batteries. By this way, that whenever the energy supplied to the any atom, whatever the outermost shell which is holding an electron, that will jump from here to here, here to here, here to here, and there is a flow is happening. The flow is happening. That flow will generates a concept called electricity. Okay, this is very important. What I told you, the outermost shell which is holding a last electron, that will come out easily. I don't think easily. We need to apply some energy. What type of energy that I told you? That is batteries are there. Batteries are very, very important for the transfer of this electron from one atom to the another atom. Now you understand half of the definition. Am I right? What is that? Rate of flow of current. That is rate of flow of, what is that? Charges. Sorry, rate of flow of charges, that you got to know about the thing and how the charges are moving and the electricity got generated. What is the meaning of that rate, guys? Rate. Everything or anything. Everything or anything divided by time. It means, in our case, what is anything here? Charge divided by time. Am I right? This charge divided by time means how much charge is gonna generated in a 1 unit of time. It may be a 1 minute or 1 second. So how much charge is gonna generated within the given time, within a 1 unit of time, within 1 unit of time. It may be a minute, 1 minute or 1 second. It means in 1 minute or in a 1 second, how much charge is flowing. That is called as rate. That is, charge divided by time is called as a rate. Let me tell you one more time. The energy is gonna apply to the atoms. It is flowing from one atom to the another atom, one atom to the another atom. That flow, how much flow is happening in a 1 minute or in a 1 second, that is called as a rate. Okay. That is what I told you. That is, rate is equal to charge divided by time. Let me write down a very, very, very important formula that comes in a electricity. That is a formula for electric current. That is gonna represented by capital I. That is very important for the numericals and all, and you may get so many questions regarding this formula and all. I is equal to, very important, charge divided by time. That charge is represented by Q and the time is represented by second. Okay, this is very, very important, which is nothing but I is equal to Q by T. This is very, very important. Okay, let me tell you one thing. In an examination, definitely they'll ask one question. What is electric current which is flowing on a conductor and all by this type of charge and for the given time and all? You need to calculate by applying the simple formula. And the unit is also very important. Unit for I is, charge is going to be represented, this charge is going to be represented by 1, this is nothing but coulomb. That time is gonna represented by second. It means coulomb per second. Coulomb per second is the major electric current has one formula, that is charge divided by time. The charge is going to represented with the help of coulomb and time is going to represented with the help of second. This means coulomb per second is the SI unit for electric current. This is very important. You may get such a kind of question in a MCQ, that is in a multiple choice question. Definitely you will get such a kind of question and everything in a electric current. But you may get surprised. The unit for I, that is electric current. What is I, guys? Electric current. This unit for I is coulomb per second. What is the coulomb per second? You may get such a kind of questions in a multiple choice based in a 10th board examination. So be careful and please have a more concentrate on this. Coulomb per second is the SI unit for electric current. One thing I'll tell you. A scientist, Andrew Ampere, he did a lot of contribution in physics. Okay, don't think that he invented something, that's why we are taking his name and all. He had done a lot of contribution for physics. Because of that, on a honor of that one, that electric current SI unit got a new name called ampere. What is this? Ampere. Okay, the electric current, the SI unit of electric current is ampere. Okay, let's recall this again. What is the formula for electric current, guys? Charge divided by time. Charge is gonna represented by Q and the time is gonna represented by letter T. That what is the SI unit of actually electric current, guys? This is charge is represented by coulomb and the time is gonna represented by second. The coulomb per second is the SI unit of electric current. And one of the scientists, he made a lot of contribution in electricity. Because of that reason, we gave his name for the SI unit of electric current. Okay, got it? That is ampere. What is the SI unit of electric current? Actually, it is ampere. But actually, while solving the problem and all, you have to write down ampere only. But before, how the name comes from ampere and all, just now I told you, that is he made a lot of contribution in electricity. That's the reason we are giving a name called ampere. But actually coulomb per second is the definition for charge divided by time, because charge is going to represented in terms of coulomb and time is represented in terms of seconds. Okay, time is represented in terms of seconds. First problem that comes in electricity. Let me tell you one thing. The numericals are very, very important in the chapter electricity. Please watch my video till end. Then only you can understand the entire concept which is there in electricity. Because numerical part is very important on the examination point of view. Now this is the first problem that comes in electricity. What is that? Let me read out. Reading a problem is very important. Okay, don't forget that one and just copy the thing whatever I'm writing on a board. Okay, don't forget that one. Okay, a current of 0.5 ampere is drawn by a filament. This is a current of 0.5 ampere is by a filament of an electric bulb. It is drawn about how much minute, guys? 10 minutes. Find the amount of electric charge that flow through the circuit. Understood? What is the meaning of this current, guys? What they had given? Given is very important. Given is very important. First write on the given part of a problem. What they had given? A current. In our term, current is going to represented by letter I, that is 0.5 ampere. And the time is about 10 minutes. And what we need to calculate, guys? Charge. Charge. We need to calculate a charge. For this, what is the formula? What is the formula? I is equal to Q divided by T. This is very important. Okay. What they had given? They had given I. They had given T. We need to find out Q. In this formula, if they had given any two terms, it is very easy to calculate the another term by dividing the terms or by cross multiplying the terms. Let me tell you one thing. So many students will get confusion in a minute and second. But in our chapter, it is very important. What I told you in the previous class, that is Q is represented in terms of coulomb and the time is going to represented in terms of seconds only. For that purpose, you have to convert this minute, 10 minute into seconds. How much second is there for a 1 minute, guys? 60. It is nothing but 600 seconds. Now, put those values in your formula. The formula is gonna convert it like this. I is equal to Q by T. I into T gives you a Q. That is, it's gonna represent it in terms of coulomb. What is I, guys? 0.5 and the time is 600 seconds. That is equal to Q. What is the answer? 300 coulomb. That is equal to Q. So it implies Q is equal to 300 coulomb. So just cross multiply that one and you will get an answer. So this is very easy problem. So only one thing you have to remember, you have to convert this minute into seconds. Okay, let me tell you one more time, just recall the things. A current of 0.5 ampere is drawn by a filament. Current means I, that given I, in an electric bulb for about 10 minutes. T is 10 minutes and find the amount of electric charge. You have to calculate the charge. Charges, you need to calculate how much charge is required for the drawn of 0.5 ampere in 10 minutes. Okay. For that, I had taken out one beautiful formula, that is I is equal to Q divided by T. And I substituted those values here, I into T, that becomes Q. That I into T is nothing but 300 coulomb, that is 0.5 into 600 is nothing but 300 coulomb. There you got a value of Q for the given formula. And this is the one formula which is there in a first problem in electricity. And please understand the things properly. Okay, and please do watch my video till end and don't skip any videos, because there is a link between one session to the another session. Then you will come to know that thoroughly while understanding the things and all.